Colonel Smith, adventurer and physics teacher. I don't always teach physics, but when I do, my students never forget. Good morning, class.
Good morning, Smitty.
Okay, today we're going to learn about Newton's laws. To quote Newton, "The phenomena of motion can be used to investigate the forces of nature, and then these forces can be used to demonstrate other phenomena. The motions of the planets, the comets, the moon, and the sea." Isn't that fascinating? Do you get it?
Maybe.
I don't get it.
Okay. We're going to go on a field trip. What do you think, Arnold from the Magic School Bus?
I knew I should have stayed home today.
Sarah, pop quiz. What did I say Newton's first law of motion was?
An object in rest stays at rest until acting on by an outside force.
Yes, let's go. This is a swing set. I'm sure you're familiar with it. Sit.
Oh, this is awkward.
Okay. Now stand there. Sit there. Are you moving?
No.
Why?
Because I'm at rest and I'm staying at rest.
Yes. Do you have anything acting on you to help you move? Now move.
Oh, that's awkward.
Okay, Sarah, why are we slowing down?
Well, an object in motion tends to stay in motion until acting on by an outside force. So an outside force must be acting upon us.
Yeah, what's acting on us?
The wind.
No, good try. I'd understand why you'd find that to be confusing, but what could be acting on us?
Gravity!
Exactly, perfect.
Newton's second law is when you have the mass of an object, not its weight, because that's something different, and you have the acceleration on the object, which could be something like due to an outside force, or due to something meters per second squared.
Exactly. Okay, so do you know what these are?
Pull-up bars?
Yeah, get on one.
You get on it. I explained it.
Wow, someone's getting a 2 for effort. Okay, so
acceleration is change of velocity over change in time. So you don't have any, there's like no time for you to accelerate there because you're as tall as the pull-up bar is, so there is no acceleration because there's no change of velocity. Whereas if you go to this one, once you drop from that one, your velocity changes and increases as you go down.
good job. Great job, Sarah. Really great job. Now you can also see that in an inclined plane. Let's go over to the slide. Newton's universal law of gravity is F equals big G times m sub 1 times m sub 2 over r squared, or the gravitational force of attraction between two bodies with mass is equal to the gravitational constant times the mass of one gravitational body times the mass of the other gravitational body over the distance between the centers of the two bodies, and this explains the attractive force between two bodies. The force is measured in newtons, kilogram meters per second squared. The acceleration of an object at Earth's surface, the value of g, can be calculated by plugging Newton's second law formula, F equals ma, or force is equal to mass times acceleration, in for the force on one side of the equation, with this acceleration being represented by g, and then canceling out the smaller masses. The mass and radius of the Earth are known in addition to the g constant, which is equal to 6.67 times 10 to the negative 11th Newton meters squared over kilogram squared, so that g is equal to 9.81 meters per second squared. In a normal xy coordinate system, the force of gravity is a downward force on the object, in the y direction towards the center of the Earth. It is a long-range force because it does not actually touch the system. However, to make it easier to understand forces on an inclined plane, like a slide, it is easier to rotate the xy axis to follow the inclined angle. Then, the initial force of gravity has to be broken up into x and y components. Using similar triangles to compare the inclined plane angle to the gravity components triangle, applying trigonometry, and knowing that the force of gravity on Earth is equal to 9.81 meters per second squared, the x and y components of the force of gravity on the object can be calculated. Then, applying Newton's second law, F equals ma, the acceleration of the object can be calculated if the mass is known. The object only moves in the angled x-axis direction, because otherwise it would either be levitating off of the slide or falling through it. That is because the downward y gravity component is equal to the upward y normal force exerted on the object from the slide. A normal force is a contact force because it is the environment being in contact with the system and follows Newton's third law that every action has an opposite reaction. Gravity downwards on the slide causes an opposite upwards normal force equal and with an opposite sign to the y component force of gravity. So, unless there are no other opposing forces in the angled x-axis direction, acceleration down the inclined plane slide can be calculated by dividing the force of the x component of gravity and dividing it by the object's mass.
Physics is fun!
So Sarah, do you remember what I said Newton's third law of motion was?
Yeah, for every action there's an equal and opposite reaction, right? But I don't quite understand it.
Well, we got this right here. See, when I push down, that goes up. Try it. For my action, there's a reaction.
So when I go down, you'll go up.
Yeah. You get it?
Yeah, now I understand.
Exactly.
Yeah.
Okay. Great, perfect. We're all done. I'm so excited. I'm glad you understand. Wait, didn't I have two students? Where's what's his name? Ritam. Where's Ritam?
I don't get physics.
First law of motion. The force that's being applied by our lightsabers is equal to the mass of the lightsabers and the acceleration caused by our arms. My force is greater than your force. Try again. Third law. Every action has an equal and opposite reaction. That's why our lightsabers aren't moving anywhere. And because you just tried to fight me, you're getting an F on your next quarter grade.
Brittany. Since you're paying such good attention, I'm sure you can tell us exactly what Newton's laws are.
Actually, I can.